Good morning, students. Today we will talk about pedigree analysis. And based on my experience and the feedback of my students, I've come to understand that this is one of the very difficult portion that the students can face in the examination. Now, why I say very difficult or why do students feel difficult is when you are being given with a pedigree such as this, as on the board, there is a question that is asked whether this particular one is going to be autosomal or it is going to be sex linked. Okay, or to be specific, we can be talking about the X linked trait. Now, after you identify this, again there is a question. You have to identify whether this pedigree given the trait is being transmitted is getting transmitted in a dominant fashion or it is getting transmitted in a recessive fashion. So you have to identify whether autosomal dominant or autosomal recessive. Similarly, here again you have to find out the X-linked or Y-linked, dominant and recessive, right? And finding out this is a very confusing task for the many of the students. But once you know the technique, this is going to be very easy for you people. So I'll tell you that how to do it. After that, once you find out these, in some of the questions, they ask another little bit tricky part. They will ask you to identify the genotype. Okay. Now, again, based on the experience of my students, I would say that genotype identification is again a very difficult task for many. And the genotype identification becomes a little bit tricky depending on whether it is autosomal or whether it is X-linked or Y-linked. Now, we'll go into that also with this particular example and then with a different example. So first, we have this pedigree chart, and what do we see here? That there are, of course, the generation 1. So here we have the first generation, then we have the generation 2, and then we have generation 3. Now in these three generations, what you see is not in all the generation you have affected individual, because if I see the numbers, as you can see, it is numbered. 1 and 2 are from generation 1 and 3 to 9 are in generation 2. Now, and again 10 to 15 are in generation 3. Now out of all of these, what I see individual 5, individual 11 and individual 13 here who are affected. Whatever the trait might be, we do not know. Whatever the pattern of inheritance, we do not know as of now. But our job is to identify that. So first thing, what am I going to do? I will just look at the entire pedigree chart and I'm going to identify where we have affected individuals. Now, I'll just change this one little bit in a different way. I'll write down. So we have from the second gen, we have this one, and from the third generation, we have individual 11 and 13. Now, if you see here, if I talk about the first generation, we have nothing. That is, it is none who are actually affected by this particular trait. Now, you have to imagine, you have to understand one simple fact, that if something is dominant, right? We all know the fact, law of dominance states that whenever there is an allele, the dominant allele will always express itself over the alternate allele. So if a particular trait, let me tell you, if this particular trait I'm talking about is in a dominant form, if it is in a dominant form, do you think it is going to skip any sort of generations? Do you think that they're going to skip any part? They'll be always express themselves. So always they'll express themselves. So they will not skip any generation at any point of time. So when you see the pedigree and you find out that they're skipping generation, the trait is skipping generation, you will go for the recessive trait. So let me write down that here. So how do you find out dominant and recessive? Dominant trait here, that means present in all the generations. right? So the trait we are talking about, the disease that we are talking about, that is going to be present in every single generation. Now, if I talk about the next one, which is going to be the alternate recessive trait, that means they are going to skip generation. A very simple way to understand this: if they are going to be present in every generation, that means they are going to be dominant. They are present in every single generation. Affected individual you'll find even in generation 1. So that is why, very simple way. So you put generation 1, 2, 3, identify how many individuals are affected here, or which individual, if numbered, which individual is affected here. You find out, and you see that something is empty, something in one generation there is nobody affected. That means you go directly for the second one, which is skip the generation. That means it's a recessive trait. Very simple, no discussion on that. If they're present in every generation, you go for dominant trait or dominant condition. Now, once you identify this, it's an easy way to identify this. You have to identify the next thing, whether it is autosomal or whether it is X-linked. Now, in your standard 12th, typically you'll be asked questions from the autosomal and X-linked only. Y-linked you may not, you typically won't be asked. So when we're talking about X-linked and autosomal, you have to identify again. How do you identify that? Now, to identify X-linked and Y-linked, you have to do a simple trick. Now you have to see here, you have to observe the pedigree, and you have to find out whether the male and female are being affected equally. What do you mean by that? If in this, let's say, second generation, what we see here, we see only the male being affected. Now in the third generation, what we see only the male being affected. In this also, male is being affected. That means here all the individuals that are talking about who are affected, as individual 5, 11 and 13, they happens to be only male individuals. That means the female here are not affected. That means they might be carrier. So when you see that the male are affected more than the female, or the male only are affected, or let's say only the female are affected in some cases, you will go for the sex linked trait. And if the male and female are equally affected, let's say in this generation, second generation, we had few female also affected, that in that case it is going to be autosomal, because you all know that autosome is the same thing. There's no difference in the autosome of the both male and female, but it is for the sex link that we are going to have a X and that is XX and XY condition depending on the male or female. So when you have this differentiation of male being affected more commonly than the female, right? The females are not affected, or they simply are represented as carrier. You will say that it is going to be X-linked and not autosomal. So a very simple again way to identify that if both male and female equally affected, right? If both male and female are equally affected, here you'll go for, in this case, it is going to be autosomal trait. And if, let's say, the males are, let's say, affected, and let's say the female are carrier, okay, they are not, they have the trait but they don't express themselves. So in other words, we're saying this male is more affected than the female. In that case, it is going to be the basically X-linked trait. Okay, it is going to be X-linked trait. Okay, I'm sorry, that's not visible. Let me put it here. Okay, so this one is going to be X-linked trait. Okay, so that's the easy way to identify and know whether a particular given trait or pedigree is going to be autosomal dominant or autosomal recessive, X-linked dominant or X-linked recessive. To summarize, I will tell you very simple way. Now, first thing I will going to see here is going to be whether they are present in every generation or not. So they are absent in generation 1. So I'll go to the conclusion that they're skipping the generation. So the trait is going to be recessive. Now, second thing I have to find out, autosomal or X-linked. Now, as I said earlier, If both male and female are affected, I see that only males are affected. So if only males are affected and the females are not affected, I'll go for X-linked condition. In other words, if I'm going to summarize this particular trait pedigree, this particular pedigree that I'm having here, this is going to be very simple, X-linked recessive. The trait is going to present in the X-linked recessive form. Okay, and you all know based on your theory that there are two examples of that you have already learned about. One is going to be regarding example, you can say color blindness, and also hemophilia. Okay, hemophilia. Now sometimes in the examination what the examiner would do is they will give you that this pedigree is of color blindness or hemophilia, but many times they may not do that also. If they give you about, let's say it is about hemophilia directly, you'll, based on your understanding of the theory, you'll directly say that this trait is going to be X-linked recessive, because hemophilia and color blindness are X-linked recessive. Their inheritance pattern is X-linked recessive manner. So that's why you know directly. But if they do not give you that, they will ask you what is the inheritance pattern. You have to find out. Then based on the trick I said, based on the system I said, you have to identify. After that, let's go to the next part. What is that? Genotype. You have to find out what is the genotype of, let's say, we'll do one thing. We'll identify for all. Okay, they'll ask you for some number, but we'll do one thing. We'll identify for all of these individual what is the genotype. And to do that, let me just remove some of this part. Okay, I'm going to remove, let's say, yeah, this part. Let me remove so that it will be a little bit more clear for us. And I'm going to remove this also. So genotype, right? Oh, okay, we'll put it from top. So we all know that this particular trait is going to be X-linked recessive. Now you need to identify X-linked recessive trait. We know that it is going to be color blindness, hemophilia. See, ek baat yaad rakhna, because most of the time in your examination, you are going to get pedigree. It is going to be either autosomal dominant or recessive or X-linked recessive. X-linked dominant, typically they are not asking based on the previous year question, I can say, and they will ask you X-linked recessive only. So when we talk about X-linked recessive, first thing that comes to mind is you have to identify genotype. Genotype matlab you have to go for alleles. So you have to identify the allele. So whenever you are going to have an X-linked condition, you have to go for the allele X and Y. X and Y. So in this, let's imagine that it is of hemophilia. If they will give you that the disease is hemophilia, right? I'm going to give you for the hemophilia. Okay. So if it is about hemophilia, then you have to go for, if it is a disease condition, and we are going to have the male and female. Let me write down. So we can have XX, which is going to be your normal female. Okay, XX is going to be normal female. Okay, let me just come this side, and then we can have XY, that is going to be normal male. Then we are going to have XHX, which is going to be carrier female. Then we have XHXH, which is going to be affected male. Then we have XHY, which is going to be your affected, okay, I'm sorry, this is affected female, and this is going to be affected male. So as you can see here, because the female is going to be having 2X chromosome, okay, here and here, 2X chromosome, if one is affected, because it is expressed in a recessive manner. So if I take this example of XHY, although there is one affected chromosome, affected allele, but we have another one which is normal. So we all know that in a X-linked recessive condition, or basically in a recessive condition, recessive trait has to be expressed, it has to be in a homozygous recessive condition. That means if only we have XHXH, condition, in this case, it is going to be affected. But what happens in male is slightly different. Male, what we have is, we have only one X chromosome, and you all know there is another Y chromosome. So the moment there is any defect in the X chromosome, that is going to be expressed. Any defect, any problem in the X chromosome in the male are going to be expressed. Same thing for the Y also. Okay, for male there's a problem, because male here cannot be a carrier. For carrier, you should have two copies, same thing, two copies, and one should be expressed, another should not be. That is in a recessive condition. So here we do have a carrier condition where there is a one affected allele and one normal allele. So the normal allele is going to express itself and not the affected one. But here what is going to happen is, because both are affected, XX and XH, it is going to be affected female. But in case of male, XHY is going to be affected. Now, coming back to this particular pedigree, we have to solve this. We have to identify the genotype, and let us start that job. So here, first thing, when we see this affected individuals, let me just remove this part also, so things will be clear. Okay, yeah. So now we have three affected male, and based on this fact, you all know this, you should know. So this fact is affected male means you have to go for the genotype XHY. So if you're lucky, they'll ask you the genotype of the affected male. So very simple, affected male or affected female का अगर पूछेंगे आपको directly ये genotype डालना है. If they're asking about color blindness, I'll tell you how to solve that also. Okay, so here I'm going to write XHY, XHY, and XHY. So problem solved. For 3 I have written XHY, XHY, and XHY. So now I have to find out for the remaining. So remaining male are going to be normal, right? Agree or not? Remaining males are going to be normal. Why? Because they can be affected or they can be normal. There is no carrier condition. So all the male. So number, okay, I'm going to start with this. So here it is going to be XY. Now number 3 is again male, normal male, so XY. Number 6 is normal male, so XY. Number 9 is normal male, so XY. And number 15 is normal male, so XY. And here number 10 is normal male, so XY. Similarly, if I go for the female now, then there is a problem. Why? Because here either I have to identify whether they are normal or whether they are carrier, because there is no shading given here. So I have to identify that. So let me come to the generation 1. So in generation 1, what you see here is the fact that the male is normal, right? The male is normal. The female is not affected. That means we cannot have the female having a genotype of XH. Obviously, we cannot have it, because in that case, it would have been an affected individual. So obviously, male is normal, female is not affected. So it is either X. So in this case, it is going to be either XHX or XX. Now it is going to be X. Okay, let me just remove this particular one. So it is going to be carrier. Why? Because only when it is carrier, right? Only when it is carrier, let me write down XX or XHS or XXH, whatever you want to write. So only when it is carrier, then can the XH, which is going to be the affected allele, can go here to the male, and the normal Y allele can come here. So that means here like this, and Y from here. Only then can we have XHY condition. If it is normal, see, as I said, if the female is not shaded, it can be carrier or normal. If it is normal, then how come the number 5 is affected? So it is not possible. So to make this possible, the female must be XHX. So typically remaining things, you have to go for the same process. Here it can be XX, we can go for XX only. But again, what is happening, because you are going to have an affected individual here, male affected, that means here you are having a normal male XY. Again, this cannot be normal female. This has to be a carrier. Only then you have an affected son. If the mother is not a carrier, then you have a normal father and a normal mother, then the child will be normal. But here what is happening? You have a normal father and a carrier mother, then there is chance of the male being affected. So here the genotype again is going to be XHX. It is going to be a carrier. So if only it is a carrier and a normal male, you will have this particular outcome. Now number seven, you can put anything you like because this has nothing to do with anything else. So I'll put XX because this X can combine with this X, so there is nothing. Now here again I have to worry because here the male is normal and the female is, we don't know, normal or sorry, carrier or normal. But here the male is affected. That means it must be again a carrier. So that means you have to put XHX. That means XHS. It's a carrier. Now about this female can be normal, can be carrier, so we are not bothered about that. It can be XX or XHX. Now this female can be again anything XHX, or it can be XX, and this male already we have written it is going to be a normal male. So my dear student, that is how you solve the entire pedigree. It's not rocket science. It's very easily you can understand if you know the basics that you have been talking about for the last 20 minutes. Now, another question is, what if you're not getting this one? What if you're not getting hemophilia? As you said, I said you that hemophilia means you have the genotype here. Very simple. अगर आपको color blindness का पूछेंगे तो just replace the word H with C. That is, instead of, let's say, XHXH, you put XCXC, which is going to be affected female, and XCY is going to be affected male. So similarly, you have to change everything else. So that's an easy way to solve the pedigree. I have taken one example here and I have solved the entire pedigree on how to do it. Now what we'll do, we will take another example of let's say the autosomal, and we'll find out the genotype in an autosomal dominant and an autosomal recessive one, step by step. So that is how you solve a X-linked pedigree. So again, let me mention it. So pedigree analysis of X-linked recessive trait. Okay, so next up is going to be your autosomal ones.